Why does cold working improve material strength? Imagine bending a paperclip back and forth until it snaps. That's a simple way to see how metal can weaken. But what if I told you that by doing the opposite, pressing and shaping metal without heating it, its strength can actually increase? That's what cold working does. It's a process that makes metals tougher and harder, but how does it work? Let's find out. When you cold work a metal, you deform it at room temperature, below its recrystallization temperature. This deformation creates a lot of tiny defects inside the metal's crystal structure called dislocations. Dislocations are like little irregularities in the atomic arrangement that allow the metal to bend or stretch. When you deform the metal, these dislocations multiply and get tangled up with each other, forming dense networks. Think of it like a crowded highway where traffic jams slow down the flow. Dislocations block each other's movement. Because these dislocation networks make it harder for other dislocations to move, the metal resists further deformation. This resistance is what we call increased yield strength. The more tangled and dense the dislocation network, the stronger and harder the metal becomes. It's similar to how a chain is only as strong as its links. More links or tighter links make it tougher. At the same time, cold working causes the grains within the metal, the crystalline regions, to elongate in the direction of deformation. This grain elongation can help improve the strength and make it harder for cracks to propagate through the material. In some metals, deformation twins can form mirror image regions inside the crystal that act as additional barriers to dislocation movement, further strengthening the material. However, there is a trade-off. As the metal gets stronger, it also becomes less ductile. Ductility is the ability to stretch or bend without breaking. Cold working makes the metal more brittle, meaning it can crack or fracture more easily under stress. That's why engineers carefully control how much cold work they apply. Too much can lead to unexpected failures. In real-world applications, cold working is used to improve the load-carrying capacity of components like gears, aircraft parts, and structural reinforcements. It helps these parts last longer and resist wear. But if cold working is overdone or not managed properly, it can cause internal stresses and make the material prone to brittle fractures or fatigue cracks. So, in simple terms, cold working improves material strength by increasing the number of dislocations inside the metal. These dislocations block each other's movement, making the metal harder and stronger. But it's a balancing act. Too much cold work can make the metal too brittle. Understanding this process helps us design better, more reliable products that stand up to the stresses of everyday use.